Alrighty, boys and girls, welcome to video lesson 2-2, our video lesson on the graphs. Whoa, I need my pointer. Move my whole thing. There's my pointer. Our video on the graphs of quadratic functions. So here are our learning targets. I can find the vertex of a quadratic function. I can identify the characteristics of a quadratic function, such as domain, range, axis of symmetry, max, min, zeros, all those things, and I can graph a quadratic function presented in any form. Three forms of a quadratic function are vertex, standard, and intercept form. Alrighty, let's go. Quadratic functions, remember, a quadratic function is going to have, you got it, it's going to have an x squared in there somewhere. So, three forms of a quadratic function. We'd already learned one of them last chapter. Okay? The first one is general or standard form. I'm going to call them either one or the other. The book uses the word standard form. Okay, so standard form of a quadratic equation is y equals ax squared plus bx plus c. Please know your terms here, your terms. The quadratic term is called the a term, or the a term is called the quadratic term. The x term, the b term, is called the linear term. The b term is called the linear term. And the c term is called the constant term. There is no x in the c term. So we have our x squared term, our x term, and our number term. Vertex form we learned last time is y equals a times x minus a squared plus k. Or sometimes we do it this way, some teachers, but we won't do it in my class. Y minus k, we move the k to the other side. And thirdly, we have roots or intercepts form, which is the factored form of our quadratic equation. We have the same a. You have x minus r1 times x minus r2, where r1 and r2 are my roots or my zeros of the quadratic function. They are my x-intercepts. Alrighty. Okay. For each function, without your calculator, we're going to find the vertex and the state. If it is a max or a min, we're going to write the equation of the axis of symmetry, and we're going to find the solutions. We're also going to identify the y-intercept. So looking at this equation, f of x, or y, f of x is equal to negative 2x squared plus 2. We can think of this as either in HK form, or vertex form, or we can think about this in standard form. If this were in vertex form, let me get a marker, I would have y equals a times, that's an a, times x minus h squared plus k. And if that were the case, my a would equal negative 2, my h would equal 0, and my k would equal positive 2. If this were in general form, or in standard form, y equals ax squared plus bx plus c. Okay, my a would equal negative 2 still. My b would equal 0, and my c would equal positive 2. Okay. So if we were to find the vertex, of this in HK form, I can see now. Let me get my pointer. My h is 0 and my k is 2, so I have a vertex. Let me pencil back, at 0, 2, which is right here. And because my a is negative 2, this is going to go down. It's actually going to go down relatively fast because I have a vertical stretch of 2. Okay, so there is my parabola. Therefore now, thinking about what are some of the things I need to find. I need to find my vertex. It is at 0, 2. So my vertex equals 0, 2. Which means now my axis of symmetry is going to equal, it's always a horizontal line where x is, so it's x equals 0. Okay, and this is going to be a max because it's the top of my function. In other words, right here, my pointer, this vertex is the maximum. It's the maximum point of my graph. Okay, one other way to find the vertex of an equation when we're in general form, when we're in standard form, we're going to use the formula x equals negative b over 2a, and we will show you why that works in class. Okay, but x equals negative b over 2a. In this case, we can see now that our b, wrong button, our b was 0, and our a is negative 2. So my value for x is going to be 0 over 2 times negative 2, which is negative 4. Well, 0 divided by negative 4 is 0. So x equals 0. And now to find my y-coordinate, I'm going to take that and I'm going to plug 0 in for x up here. So I'm going to get negative 2 times 0 squared plus 2, which of course is positive 2. So we can see our vertex, once again, is at 0, 2. Okay. And this is also my y-intercept. So my y-intercept is also 2. And we always find the y-intercept by simply plugging in x equals 0. Okay, so looking at this guy right here, y equals x squared minus 8x plus 16, we're going to make a graph of this. We're going to first start, this is in standard form, so I know that my a is equal to 1, my b is equal to neg 8, and my c is equal to 16. We're going to start by finding my vertex using the fact that x is equal to negative b over 2a. So I'm going to make a little list over here, my vertex. Okay, my vertex is my x. I'm going to plug in b, which is negative 8. So negative 8 over 2 times 1, a is 1. I'm going to get positive 8 over 2, so x equals 4. To get my y now, I'm going to plug 4 into my equation. So I'm going to take my 4, which is right here, and I'm going to plug it in for x up here. So I'm going to get 4 squared minus 8 times 4 plus 16. So when I do that now, when I do that, I get 16 minus 32 plus 16. I'm getting that from these numbers right here, right? So that now looks like my y is 0. So I have a vertex at x equals 4. Y is 0. So I have a vertex right here at 4, 0. And the fact that a is positive means this thing goes up. Okay. My axis of symmetry, of course, is the x-axis, the x value that passes through the vertex. So it's going to be this vertical line right here. My axis of symmetry is going to be x equals 4. Now, to find the y-intercept, all we're going to do is we're going to plug in my y-intercept. We're going to plug in x equals 0 into our function. So when I do that up here, let me get my pointer. When I plug in 0 in for x up here, because remember on the y-axis, x is always equal to 0. So I'm going to plug in 0 for x. I get 0 squared minus 8 times 0, which is 0. 0 minus 0 plus 16. So my y-intercept, let me get my marker, my y-intercept is going to be positive 16, because when x is 0, we get positive 16, so my y-intercept is going to be way up here. If I were to extend my curve, it would look like that. Okay, the intercept form of a quadratic equation is f of x or y. F of x is equal to a, again, it's the same a, times x minus p, or before we said r1, times x minus q, or r2, where p and q, or r1 and r2, those are my roots. Those are my roots. So when you look at the graph, it's the factored form of your equation. My x-intercepts are always going to be p and q. So these are what we call my roots. Notice my axis of symmetry is always going to be halfway in between my two roots. So the vertex of an equation of a quadratic function, when it's written in roots form, is always going to be halfway in between my roots, or the average of our roots. And the average of two things, of course, is you add them up and divide them by 2. So you find your x by taking p plus q, our two roots, adding them up, dividing by 2, and you find the y by plugging that x in.